Good day, everyone. I want you to picture something for a moment. Imagine you are leading an industry that is rapidly evolving, where innovation is no longer a luxury but a necessity. The global industrial landscape is shifting towards IR 4.0, a revolution driven by smart technology, automation, data-driven decision making. Industries that embrace innovation and continuously learning are shaping the future, while those resist change risk being left behind in this rapidly moving revolution. The IR 4.0 is transforming how businesses operate, from automated production lines and smart factories to data-driven decision-making with artificial intelligence. As industries evolve, so do the challenges they face. Rising customers' expectation, stringent quality standards, increasing production complexity, and a demand for faster, more cost-efficient solutions. So, ladies and gentlemen, it is no longer enough to rely on existing methodology together with the current quality control measurements. Companies that wish to remain competitive must invest in knowledge and skills that allow them to optimize processes, reducing waste efficiently, improving product reliability, and adapt technology advancement. Each of the courses that we are going to discuss here is designed to tackle the critical pain points that every industry faces today. We are talking from minimizing production defects towards enhancing quality in making a smarter business decisions through data-driven analysis. These courses under Smartrix are the structured approach to achieve operational excellence. Let's ask some fundamental questions. How can businesses prevent product failures rather than dealing with them after they occur? We are talking about reliability engineering. How can companies ensure accurate measurements for better decision making? We are talking about measurement system analysis. How can manufacturers optimize product design and production processes to maximize efficiency? We are talking about design of experiment Factorial and Taguchi robustness. How can organizations develop defect-free products from the start? This is where design for Six Sigma comes in. How can industries ensure quality without testing every single unit? We are talking about acceptance statistical sampling. How can business use past data to predict future trends and make quality-based decisions? We are talking about regression and predictive analysis. How can companies maintain consistent quality and detect process deviations before defects occur? We are talking about statistical process control. And finally, how can industries eliminate inefficiencies, reduce costs, and continuously improve their operation? We are talking about LeanSixSigma DMAIC. These are the questions that every industry must answer to survive and thrive in a rapidly changing world. The good news is, all these challenges have solutions. Let's explore each of these courses in depth and understand their profound impact with real-world applications. Let's begin with reliability engineering. Reliability engineering is the backbone of long-term product performance and customer satisfaction. Imagine investing millions in a product only to have it fail within months. This is something that can really affect the brand reputation. And it can also lead to high warranty costs and safety concerns. Reliability engineering helps organizations design and implement a robust system that can withstand real-world conditions. Without reliability, industries can face production downtime, high maintenance costs, and worse, dissatisfied customers. In the industry, dissatisfied customers are the curse. Industries like automotive, aerospace, medical device, food and beverages, textile, and semiconductors, failures is not an option. For example, automobile manufacturers, they will rely on reliability engineering to enhance battery life and reduce vehicle malfunctions. This results in fewer recalls and higher customer trust. In aerospace industry, every aircraft component from jet engine to landing gears must endure extreme conditions. This is where reliability engineering helps prevent catastrophic failures, ensuring passenger safety and operational efficiency. How about food and beverage industry? Reliability engineering in its bottling plants will help to ensure consistent production and reduce downtime. Textile industry, reliability engineering to prevent defects in fabric production and ensure consistent quality. Semiconductor industry, reliability engineering will be applied to optimize chip performance and durability. Decisions in manufacturing and quality control are only as good as the measurements they are based on. Measurement system analysis is essential in ensuring the accuracy, repeatability, and reliability of measurement system. If measurements errors go unnoticed, they can lead to defective product, production delays, and compliance failure. Companies often rely on data to make critical business decisions. But what if this data itself is flawed? In industries like pharmaceuticals, semiconductors, food and beverages, electronics, automotive, and textile, to name a few, a minor measurement error can result in mass product defects, costing companies millions in recalls and legal liabilities. This cost will empower organizations to evaluate and improve their measurement system, making a good data-driven decision which is more reliable and trustworthy. For further examples, like semiconductor industry, when they are producing microchips, even a small 0.01 millimeter error can lead to a defective product. Measurement system analysis will ensure high precision measurement for consistent quality for such critical industry. If we look at food and beverage industry, let's look at Coca-Cola. They will ensure that every soda bottle is filled with the exact quantity of liquid. Let's look at electronic industry. A company like Samsung will definitely apply measurement system analysis to ensure precise measurement in smartphone component assembly. If we look at recently, a Pfizer manufacturing facility, of course, they will use precise ingredient measurement in their pharmaceutical production, where MSA comes into action in maintaining compliance with global health regulations. Innovation is the heartbeat of industrial progress, but how do we ensure that we are making data-driven decisions rather than relying on trial and errors? This is where design experiment Factorial is a powerful statistical tool that helps industry systematically test multiple variables at once. DOE Factorial also identify the optimal conditions for improved performance, for cost efficiency, and also for the right product quality. DOE Factorial is widely used in product development, process improvement, and quality assurance across industry, regardless it is automotive, electronics, semiconductor, food and beverages, and textile, to name a few. By implementing DOE Factorial, we can investigate the different combination of variables, and industry can minimize waste by shorten the development cycle and maximize the overall efficiency. Let's look at several examples on DOE Factorial. Automotive industry, they will use DOE to optimize fuel injection system, enhancing fuel efficiency while reducing emissions. If we look at electronic industry, applying DOE Factorial to test smartphone screen durability under different temperature and humidity conditions. If we look at food and beverages, they will optimize the formulation by adjusting their food contents through factorial design. If you look at semicon, another example here, DOE Factorial will be used to fine-tune wafer fabrication process, and therefore it can lead towards the improving the microchip durability. We have another design of experiment approach that is known as Taguchi robustness. In the real world, which is full of uncontrollable variations, such as material inconsistencies, temperature changes, Taguchi robustness help industry in designing process and products that can perform consistently under these uncontrollable variations. Taguchi focus on making process less sensitive to this variation. Therefore, we can look towards building in quality into the design rather than relying on the after-the-fact quality control measurement. This approach is widely used in many industries, regardless it is semiconductor, electronic, textile, food and beverages, automotive, to name a few. Let me give some examples here. If you look at automobile industry, Taguchi method definitely will be used for ensuring a good paint finishes that will remain durable under various weather conditions. If I use Taguchi robustness in electronic industry, it is definitely used to enhance the lifespan of lithium-ion batteries in portable devices. If you look at food and beverages industry, for example, we can talk about a beverage, maybe like Coca-Cola again, where these Taguchi principles can optimize carbonation level in soda production under different storage conditions. In semiconductor industry, if we are looking at designing the chip with resilience against environmental factors like heat and voltage fluctuation, we need to employ design of experiment Taguchi method. Quality is not about fixing the problem alone. It is also about preventing them from happening in the first place. This is where Design for Six Sigma with DMADV, define, measure, analyze, design, and verify, will be used to ensure that the product and the process that we build is built with the quality and customer satisfaction in mind right from the very beginning. This method is actually crucial in high-tech manufacturing. It is also crucial in other critical industries like aerospace, automotive, semiconductor industry, where we can't tolerate even a small defect being released into the market. Unlike traditional Six Sigma, which focus only on improving existing processes, DFSS aim to create a defect-free design from day one. Let's look at some examples in the industry. If we look at automotive industry, we can use DFSS to develop a good electrical vehicle battery system, which has a good performance and longevity. If we look at electronic industry, if we look at DFSS here, it will be used to ensure that the smartphone's processor design is optimized for performance and power efficiency. Let's look at textile industry, for example. If we look at a branding company like Nike, they definitely use DFSS to design high-performance sportwear to meet the durability and the comfort standards of their intended customers. In semiconductor industry, company like Intel will definitely incorporate DFSS in their microprocessor design to ensure speed, power efficiency, and overall reliability of their components. Manufacturing excellence is also all about consistency and precision. We also talk about an effective quantitative preventive action. Always remember that prevention is always free. Defects is something that we can't afford. Repairing, rework, worse still scrap is something that is a big problem for organization. This is where we are going to talk about statistical process control, which is a powerful quality control methodology that enables company to monitor and improve their processes in real time. We are talking about implementing an effective preventive action that will trigger the symptoms before the defects occur. Therefore, organization can maintain high standards. SPC is widely implemented in every industry, regardless whether it is semiconductor, automotive, textile, food and beverages, energy industry, where we are talking about even a small process deviation can lead to significant quality issues. By tracking performance data, SPC can help all these organizations to detect and correct problems before they can even occur. Let's look at a few examples. Automotive industry. SPC is definitely used to track and maintain precision in assembly, ensuring compliance with stringent regulatory requirements. If you look at electronic industry, SPC in microprocessor manufacturing to identify variations and minimizing defects. Semicon industry, SPC, can be used to track and maintain process stability in wafer fabrication. Finally, we can look at another industry, let's say food and beverage industry. We can use SPC in bottling operation to ensure consistent liquid fill levels and carbonation. In large-scale manufacturing, inspecting every single unit is often impractical and almost impossible. This is where acceptance statistical sampling provides an efficient solution by using a statistically valid sample size to determine the quality of an entire batch. Acceptance statistical sampling is the last barrier to ensure that defect doesn't reach the customer. Therefore, this method ensures the quality control while maintaining production efficiency. By employing the right approach of acceptance sampling, we can reduce the cost, increase efficiency, while preventing defective products from reaching consumers. Acceptance sampling is critical in every industry where mass production requires an efficient method to validate the product's quality before shipment to end users. Let me give you examples. If you look at electronic industry, statistical sampling can be used to test television screen for proof defects before distribution. If you look at food and beverage industry, we can apply statistical sampling to check for bottle seal integrity before shipment. If semicon industry, statistical sampling can be used to ensure the quality of the wafer before integrating it into microchips. And finally, if we look at automotive industry, we can look at statistical sampling to verify the quality of thousands of brake pads before assembly. Data is often referred to as the new wealth. Its true value lies in how well we analyze and use it to derive decisions. Regression and predictive analysis allow industries to leverage historical data to forecast trends, optimize production, and improve decision making. This approach is critical in finance, healthcare, retail, automotive, semiconductor, electronics, textile, basically almost every industries. This is where an accurate forecasting and proactive strategies can lead to reducing costs, increasing efficiency, and better risk management. Let's look at several industries. If we look at automotive industry, we can use regression and predictive analysis to forecast vehicle demand, and therefore we can optimize supply chain logistics. Meanwhile, in electronic industry, we can apply regression analysis to predict smartphone battery life under different usage conditions. If we look at semicon industry, we can use this predictive model to identify chip defects before they occur, and this can lead towards improving production yields. LeanSixSigma is widely adopted in every industry where minimizing waste and optimizing processes are critical to maintain competitiveness in a fast-changing market. Every business strives for efficiency, consistency, and waste reduction. And to achieve this goal, we will use DMAIC methodology. D stands for define, M measure, A analyze, I improve, C control. This methodology will help every process manager in the organization to identify waste, eliminate them, and reducing variation as much as possible. DMAIC is a continuous project improvement, and it must be mastered by every single organization. Let's look at some examples. If we look at automotive industry, we can use DMAIC to reduce production cycle time and improve defect detections in assembly line. In food and beverage industry, I strongly believe those global fast food chain like McDonald's or KFC, they apply Lean Six Sigma principles to streamline kitchen operations, where they ensure faster service time and consistent food industry. Meanwhile, if we look at electronic industry, Lean Six Sigma can be used to enhance supply chain efficiency where it can lead towards minimizing inventory waste and reducing the lead time. In textile industry, we can look at using DMAIC to optimize fabric cutting processes while minimizing the material waste and improve the garment consistency. In the end, IR 4.0 is not just about automation and technology. It is also about people, processes, and precision. The companies that survive and thrive in this era will be those that continuously invest in learning, improvement, and innovation. Think about the industries that fail to adapt. Once dominant companies that refuse to embrace change have faded into irrelevance. The difference between companies that lead the market and those that struggle to keep up is their commitment to learn and develop. Training employees is not just a corporate responsibility, it is an investment in a company's future success. Company that build a culture of continuous improvement, company that emphasize on quality will see higher productivity, reducing costs, better product quality, and increased customer satisfaction. A company that only think of quality will always remain dominant in the industry. It is all about maintaining and increasing customer satisfaction. Whether in manufacturing, healthcare, electronics, automotive, food production, or any other industry, the companies that proactively equip their workforce with the right skill will be the one that set the standards for excellence in the coming era. The time to act is now. Businesses that embrace these methodologies will not only survive but will thrive in the age of automation, AI, and data-driven decision making. We are talking about the age of IR 4.0. Those that delay will risk being left behind in this fast-moving world. IR 4.0 is moving very fast exponentially. This era will not wait for anyone. So, to HR managers, industry leaders, and decision makers, this is your opportunity to create a workforce that is resilient, well-skilled, and ready for the future. Equip your team with these industry-critical courses and position your organization at the forefront of quality excellence. Thank you for your time, and let's work together towards building a world-class quality organization. See you. Let's seize this opportunity. Upon completion, participants will receive a certificate of competency from IQM, Institute Quality Malaysia, which includes a year free membership, along with a certificate of competency from Smartrix Consultancy, endorsed by Malaysian Board of Technologies, MBOT. These certificates and membership will significantly enhance participants' credentials and support their ongoing professional growth in the quality field.